So we're in 6.4, we're doing things a little bit out of order. We already trade graded a small ion quiz that didn't seem worth videotaping the grading of an ion quiz. I'm going to do some examples that help do homeworky stuff next. So the homework that's going to grow out of this 6.4 lesson is 1JK, and I'm not just kidding about that, 2C, and then working from 6 to 9 toward the end of the chapter. So if you look at 6, 6 is going to say diagram the ionic structure for each of these ions, indicating the number of protons and neutrons in the nucleus, and then arrange the electrons into principal energy levels. And they'll give you something that looks like this. So we've done this before. This is just a small twist on what we've done before with this. What do they have in mind for us to write first?
The chart thingy.
No. Easier than that.
11 protons, it's the protons.
So what would I even have to do before I can even do that? Draw a nucleus. So I'm going to have to draw myself a nucleus. Who lives in the nucleus? Okay. And how many in this case?
11
There are 11 protons in there given by this number.
12 neutrons.
12 neutrons given by subtracting those numbers.
11 electrons.
Which usually means there's 11 electrons, but not anymore. We live in a chapter with a thing called ions. Ions mean that there are electrons either gained or lost. So if there's, how do we know? We see the sign, we see a sign of plus. That means if we have a positive charge,
We're losing electrons.
we lost an electron. So there aren't 11 electrons like usual, there's 10, and then we need to separate these into levels. So the first level holds 2. The second level can hold 8 before we start to like go in weird wonky orders, but we'd be good on that. Question about that? So much fun, let's do it again. So this one, draw a nucleus,
17 protons.
17 protons, 18 electrons, one small logical, or
Gaining an electron.
18 neutrons I meant. And
Well,
then
I mean, it will be 18.
a small logical difference on the electrons
We gained an
is
electron.
we gained an electron, so there's not 17,
There is 18.
there is 18. So we have 2 electrons,
8 electrons.
8 electrons,
8 electrons.
and then 8 more electrons. If we get up beyond a certain threshold, what do we have to use to do that? That short. That didn't affect us here though. I don't know if it affects the homework, I'll look in a second. Question there? By that chart, we mean this. So 2, 4, 10, 12, 18. If we're working up through 18, we're good. Because the 1 fills before you touch 2, 2 fills before you touch 3, but then you start the 4 before you finished 3. So if we get higher than 18 electrons, which we didn't over there, then you have to start to think about the chart. The other code word you have to think about the chart is the code word sublevels. And that's going to be in the homework today. Number 7 says write the electron configurations in sublevels for these. So we're going to have to do some charty stuff. Looking at homework for number 6, where we're doing the structures with nucleus, you will not have to ever do the flow chart. The highest number we see on this is a 16, and maybe we even gain a few electrons above a 16, but it's not going to go more than 18 on you. 7, they're mostly like 18 and less, but they do pop you one up that's in the 30s. So we're going to have to go a little bit beyond where we're going to flow in this one. But how many electrons in this? 18. because there's normally 20, but we lost 2. So we're gonna have to go 18 electrons worth. So 1s, 2, 2s, 2, 2p, 6, 3s, 2, let's do a count. Where are we? We're at 12. So beyond 3s, 3p, 6, we're at 18, we're good. And that's almost the right answer. What did I forget on purpose?
Commas.
Commas. How many commas? 2. One after the 1 before the 2 starts. One after the 2 before the 3 starts. But that's what you're doing tonight in this homework. 6 is this, 7 is that. 8 and 9 are just like questions, but 6 to 9, do your best you can with that, along with some of those letters and stuff. While we're looking at homework page, does anybody need anything on 4 and 5, doing the oxidation number math, where we were trying to add stuff up to 0 and or add stuff up to what the charge was? Anybody, anything about that stuff? Okay, so the only quiz we'll do tomorrow is the ions. Just go crazy studying for the ions. Ions quiz tomorrow. The next day, we'll put the ions aside and we'll go into the 6-5 quiz, which you have a study sheet for. And in the meantime, we might as well go after the 6-4. So let's trade grade to 6-4. We'll crash through this because we've got about 5 minutes and I think we can do that. Nobody has any homeworky questions? All right, so 6-4s, here we go. 1 is a thing called an ionic bond. 2, you have 5 choices, pick 2. So possible choices, transferring electrons can result in great changes of properties. Or 2, charge on ions is related to the protons and the electrons. Or the radii of ions are different than the radii of atoms. Or energy gets given off in bond formation. Or the smallest unit of an ionic compound is called a formula unit. It's not molecules anymore because it's not made of the same stuff. If anybody put that not all ionic bonds are one-to-one exchanges, I'll even take that. That was not it was beyond number 5 and it wasn't number 6, but it was the next thing they said and it's true and it didn't make the quiz. So if anybody said that, I would take that. 4 is formula unit, and then I'll pause for a second about scoring any of that. Anything there? Tomorrow when we have more time, I'll add on some more notes to that, but right now there's just not time to really expand on that, so to be determined on notes on this. 5 is attractive forces that hold atoms together. 6 is ionic and covalent. 8 is valence electrons. If they just didn't say valence, go half. 9 is 8. 10 is helium. 11, 12, 13 is lose, gain, share in that order. 14 is energy it takes to remove an electron. 15 is the energy that gets given when an electron or when an atom gains an electron. So both of those look for energy. 14 key thought is removing an electron. If you're not removing an electron, you didn't score. For 15, if we're not gaining an electron, you didn't score. 16 is an anion, 17 is a cation, 18 half a point for saying Roman numeral, the other half for left is positive stuff, right is negative stuff on the table. 19, 0, 20 is 0, 21 is ionic charge, 22 you need sum in there, it's the sum of the oxidation numbers. Should say of atoms, but if you left that off, I'll live without that. But sum of oxidation numbers of atoms is best answer. Positive is 23. Electronegative is 24. More on that next time you read. 25 is a plus 1, and 26 is a minus 2. Don't mark it wrong over this, but unlike the charges on the ion quiz, the oxidation numbers are different. You write the sign before the number like you do in normal math stuff. So positive 1 and negative 2 are written like they're usually written in life.
What was 24?
24 was electronegative, which is one really long word. Anybody scoring of 6-4 question? We're down to less than 2 minutes, so I'll have to explain what these mean another time. We'll fill in the 6-5 study thing maybe another time, but make sure you don't lose your 6-4 so we can talk about some stuff on that. We'll do that tomorrow after we do the ions quiz. And that's a wrap on that. So here's some 6-4 notes that help you prep ahead to 6-5. So when I gave you the study guide little paper for 6-5, there's 8 new points. Did it show that for you?
Yeah.
Okay, so there's 6 that are going to be very obvious because they're super highlighted, bolded, and put into margin, and they're every which way you could find them. So there's 6 dead giveaways. The other piece of this is what most of the days have had. They get to a point where they say there's 4 main points about this: first, second, third, fourth, and they make 4 like main points. I'll ask you to pare it back 2 of those points. So be ready to know 2. Pick 2 of those 4 and have those for me. Then compared to the one we graded yesterday from 6.4, you can see most of this stays the same for a while. It's the final farewell for a few of these questions. So like, what is a chemical bond is still there, and that one will live on because that's a main theme of the chapter. The ionic and covalent answer will still live on because that's a main theme of the chapter. But the stuff that was from 8 through 15, that's still there tomorrow, but that's the farewell for those because it's about time we need to start shrinking some of these words away. Basically then from what is a chemical bond to the bottom, that's all still alive, but some of it's getting ready to get ditched. Then what changes is some notesy kind of stuff from the top. The top 4 of yesterday's is going to become the bottom like 10 of the next one. So we need to kick this in on 31 on the study paper. It's 31 on the study paper. What is an ionic bond?
Yeah.
Okay, so what is an ionic bond? You could grab from that other paper if you want, but go with force of attraction between ions of opposite charge that holds them together. But that's just word for word taken from the 6-4, so instead of me repeating that, just steal it from your 6-4 paper that you're looking at. From the second sentence in number 1, I'll have a follow-up question. What happens to electrons in this kind of bond? And they are going to transfer is the word we're hunting. So what happens to electrons in this? They're going to transfer. Because something that has only 1 electron, we have talked about, wants to give it away. And somebody that has 7 wants to gain it. So that's exactly what's going to happen is that the ones with only a couple electrons that seem worthless to them, they're going to give them away, and the other ones are going to take them. And that's going to end up drawing these things together, because if you have something gives away an electron, it becomes what charge? Positive. Something gains an electron, it becomes negative. And in the world of charges, opposites
repel or attract.
Opposites attract,
Same
and that's gonna get them together. Then yesterday you were saying 5 of the points. The 5 of the points become these fill-in things. So you can see on your paper, the transfer of electrons can result in great changes in blank. It is properties. So to illustrate this is sort of funny to me. You may or may not think this is funny, but the first 2 things I say aren't funny, but sodium is poison. That's not funny. Chlorine is poison. That's not necessarily funny. But if you put sodium and chlorine together to make sodium chloride, that is table salt, which is quite not poisonous. But sodium on its own is a poison. Sodium on its own explodes if you put it in water. Sodium on its own is a solid that you can cut with a knife. Chlorine is a green poisonous gas, but you put those together and it's salt. So for sure, you can get great changes in properties, because the things that are true about sodium and chlorine are not at all true about sodium and chloride. 34, anybody have that one in mind?
Number of protons and electrons.
It's the protons and electrons in the ion. So 34, we're filling in the blank with protons and electrons in the ion. 35, anybody a thought?
Radii.
Is radii, which is the plural of radius. Someday, for extra credit, I have a long thing that you can say. So if you're interested in jotting this down so you have it somewhere, feel free. It's going to be probably like 3 sentences-ish, and then the reverse is true as well. So a total of like 6-ish sentences. But here's the scheme on this. If we gain electrons, the nucleus would attract each of those electrons less. Kind of like if you were at a school with 20 boys or girls, some of them might be attractive just because you've got to be attractive to somebody. But if you got 40 new boys or girls and there's 60 now to choose from, those original 20 might not quite seem as attractive anymore because the numbers have tilted the other way. But anyway, if we're gaining electrons, the nucleus would be attracted to each one of them less. The electrons would also repel each other more. If there's more electrons, they're going to like repel and try to get away from each other because like charges repel. And therefore, that atom would get larger. And if I go in reverse, all the reverse is true. If we lost electrons, the nucleus would be attracted more to them. They'd repel each other less. You might also even lose an energy level, but it's going to be smaller. 36 of thought
Energy?
is energy. So it takes energy to break bonds. Therefore, it makes sense that it would energy be given off when you form bonds. So breaking bonds requires energy going in, so making bonds would require some energy coming out. 37 is formula units. 38, what I'm meaning by one-to-one exchanges is NaCl is a formula where one Na goes with one Cl. NaCl, one of each. Do you always have to have one of each on these electron shares, electron transfers? No. There is like an Na2O, where there's 2 Nas, each give up an electron, because oxygen actually doesn't want one, oxygen wants to pick up 2, because oxygen's in column 6, oxygen in column 6 wants to take 2. So if Na is willing to give some up, it'll take 2 NAs giving up 1 apiece. But moral of the story, 38's no. 39, anybody know?
High melting point.
High melting point is 1.
Conduct electricity.
Conduct electricity as liquids or in a solution. So that answer's a little longer than you might like it to be. But high melting points is 1. Conduct electricity as liquids or in a solution. And that's probably a wrap for all of that. I don't see anything else I don't think that I want to say. So we're good there. Anything, anybody, run it back? So tomorrow there's not an ion quiz. Tomorrow is just this 6-5 quiz that we previewed. And that's a wrap.